So once you've created your data visualizations, you may be wondering if your results are significant or if they're more likely to be influenced by random chance. So there's a few things that we can do in both Sage Modeler and Google Sheets. If we have means of different categories, you can tell overall where there are the most plankton species in which season and where there were the least plankton species observed. But as you can tell, there's also a lot of variation. Some days are just higher and lower, not relative to the season. So one thing that we can do to help kind of visualize this is in the toolbar, you can add a standard deviation. And standard deviation is a measure of the variation from the mean. So these smaller standard deviations here, this is one standard deviation below and above the mean, means that our data is more closely clustered towards that mean. Whereas this one, our standard deviation is huge because we have a lot more variation in the data. If our standard deviations overlap between our different categories, that could be an indication that our results are not likely to really indicate a significant difference between them. You know, there's a lot of high points up here and down here, even though the mean for this one is higher than this. So our overlapping standard deviations are kind of an indication that that difference might not be significant. If we've got a trend line, there's a couple things we can do to better understand how likely this line is to be representative of our data points. In Sage Modeler, when you add a trend line, it includes the equation. So one thing you can look at is the slope of the line right here, negative 0.0228. So a negative slope means our plankton were decreasing over time. And the 0.028 is the slope of our line. So a very shallow line because that's a very small number. So not a big decrease over time. We can then also look at the R-squared value to understand how well the data fits to the line. So for our R-squared value, if this was 1, that would mean our data points fell exactly along this regression line. If it was 0, it would mean that there was absolutely no correlation and our numbers don't fit to the line at all. This 0.072 is a pretty small number, so our data is really varied and doesn't fit very well to this line. So not all of this data is representative of the line here. That could be an indication that our data might be influenced a lot by random variation. You can do a lot of similar things in Google Sheets. Once you have a bar graph with your different means for each season, so there's a slightly larger data set here, which is why the data looks different. You might wonder if the differences are real. We can also calculate standard deviations in Google Sheets. Similar to averages, it will just be an equals, stdev, parentheses, and then select the data that you want included, the same data that you included in that average. Once we have a standard deviation for each of our means, you can add error bars to any of these graphs. So if you right-click, go to Series, and select the data, the first thing you'll actually want to do is hit Switch Rows and Columns, and that just makes our data points independent. And then in Customize, you can select whichever. I'll start with winter since I just calculated that standard deviation because it's a different one for each standard deviation. Add error bars, go to constant and enter in whatever the value was. So 1.388 is I believe what we have here. And you would go in and do the same thing for each of your different. For spring, you would change it to the value here, and then you have standard deviations. And again, if we have a trend line, you can add the R-squared value. If you go to Series, select the data, and under Customize, Trend Line, select Show R-squared value. So here our R-squared value is 0.02, so still very small, which makes sense because you can see quite a bit of variation in the points over time. So those are just a few ways to help you better understand variation in your data and try to decide if your results are statistically significant or more likely to be due to random chance.